Yeah, thank you for joining this lesson. We're going to continue with the Kcse 2024 examination, Physics Paper 1 revision. This time round, the section 2. So I hope you will cooperate till the end of the lesson. I would request you to kindly share the lesson with a friend, invite people so that we may learn together. Just click the share button. Click the share button so that you may bring on board any friend of yours who is willing to learn with shifting grades. So let me bring the paper to you. Remember, the section 1 of this paper has already been discussed in this platform, Shifting Grades Online School. So all the questions in section 1 have already been uploaded. And this section will be now dealing with the section 2. It's good I remind you that our consultation line is still 0704153366. So in case of any queries in mathematics and physics, feel free to inquire through this line. Number 14 is the first question in section B, 55 marks. Answer all the questions in this section in the spaces provided. State the meaning of the term relative density. Yeah, state the meaning of the term relative density. We should know that relative density is the density of a substance in relation to the density of water, or relative to the density of water. So the density, the ratio of the density of a substance, the ratio of the density of a substance to the density of water. So it's a ratio. And just to put it across, people should understand that a relative density has no units. It is the density of a substance to the density of water, a ratio for this case. Yeah. State 2 areas of application of relative density in daily life. It is used to determine the density of unknown substances from the density of water. Determining density of unknown substances. Determining unknown, let me check the spellings. Unknown densities of substances. There are many uses. We can just give two of them. It is also used to test the purity of substances like water, used to determine the purity of substances. The purity of a substance. E.g., can talk of the density of milk, among many other applications in real life. Okay, in part B of number 14, a student blew air into a balloon, tied it up, and released it into the air. It floated for some time, but slowly descended to the ground and settled. So look at this now. We are taught to explain why the balloon settled on the ground. Why did it happen that? It initially began by going up. It started by rising. Then after some time, it now started coming down. So initially, you can say, initially, initially the weight of the balloon and the air is lighter or is below the weight of the air around it. That is, the air inside the balloon together with the fabric making the balloon are having a weight which is lesser than the weight of the air around the balloon, or weight of the air displaced. The air displaced by the balloon. The air displaced by the balloon. In other words, this is upthrust. So now that upthrust is being greater than the weight of the balloon is going to float. The balloon is going to float. So we can say when the air in the balloon cools, the air after some time now in the balloon cools, increasing the density. Hence, the balloon settles down. It settles on the ground. Yeah, we can say on the ground. It settles on the ground. Settles on the ground. Yeah, that is one thing that you're supposed to understand. Again, state two ways in which the balloon could be made to keep floating in the air. Remember, it is coming down because at some point the air has cooled. So if we keep it hot, if we keep the air hot inside the balloon, then it is going to remain lighter and hence it will keep floating. So keeping the air hot, keeping the air in the balloon hot. Keeping the air in the balloon hot. That is to ensure that it remains less dense and hence floating. And hence floating. We can also expand the capacity of the balloon, increase 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 the capacity of the balloon. Remember, when the capacity of the balloon is increased, this will make the balloon to displace more air, and hence the balloon is going to experience a greater upthrust that will make it to keep afloat. That is what you're supposed to know. The balloon will keep afloat because it is now able to displace more air in the outside, making it experience a greater upthrust. Remember, upthrust is the same as the weight of the air displaced. Therefore, now we will have the balloon floating. A hollow metallic cube of volume, 1,000 cubic centimeters, is submerged in a liquid of density 1,100 kilograms per meter cubed. Determine the upthrust acting on it. Upthrust equals to, it's good to know, upthrust equals to weight of fluid displaced. Weight of the fluid displaced. So if the volume of the metallic cube is 1,000 cubic centimeters, then it shall displace the same volume, but of a liquid now, whose density is 1100. Therefore, we can say that mass is usually given by density times volume. So can we talk of a density of 1.1 and a volume of 1,000? I've changed this one to 1.1 grams per cubic centimeter by just dividing it by 1,000. So this is going to be equivalent to 1100 grams. If this is the mass, we can make it weight. Therefore, upthrust, which is equal to the weight, will be mass times G. Mass, we make it as a unit by dividing by 1,000, then times G, which is 10. The value of G has already been provided here. It's 10. Therefore, we're going to get exactly 11 Newton. Now, 11 Newton is the upthrust acting on the hollow metallic cube. We are the second question. Remember to subscribe to this platform and to also share the link with friends. As we continue learning, bringing to you the approach through which you're supposed to acquire airtime through. So you just go to your M-Pesa, Lipa na M-Pesa, then the pay bill number is displayed very well, 737356. Then the account number is the phone number that you'd like to purchase airtime for. After you enter the account number, now you proceed to enter the amount and you complete your transaction. Airtime will reflect instantly. So the pay bill number can be mastered very easily, 737356. Then account number is your own phone number. Then after that, now you can somebody from Malawi is following up with our platform tonight. Thank you so much, Jumpe from Malawi. Thank you. Thank you for being around. Thank you for following with our platforms. I would request people from Kenya and beyond to just subscribe to this platform and to share with friends so that people may also benefit. Otherwise, I'm grateful. Thank you for being around. We proceed with number 15. The question says, during an experiment to verify a certain law, a student was provided with some masses, a spring, a meter rule. State the law the student wanted to verify. So when you see masses and springs, and we can see a meter rule, then definitely we should think about the Hooke's law. The Hooke's law. The Hooke's law. All right. Part 2. State one other apparatus the student needed in order to carry out the experiment. So in order to carry out the experiment, the student now requires a complete stand, or a stand, a clamp, and boss. A stand, a clamp, and a boss, or simply a complete stand. When a student says stand, that student knows what they are talking about, because a complete stand will be having the stand, the clamp, and the boss. That way now, the student will be in a position to perform an experiment to verify the Hooke's law. Part 3. How would the measurements taken during the experiment? Explain how the measurements taken during the experiment are used to verify the law in part 1 above. So the law that we have mentioned, which is the Hooke's law, how will it be verified? This learner is supposed to hang the masses on the spring. Of course, you start with the original length of the spring when there is no mass hanging on it. Then after that, you start hanging masses one at a time. You record the new length. Then now from the new length and the original length of the spring, you can determine the extension caused by the mass. You add a bigger mass, you again confirm what the new length is, you subtract it, or you subtract the original length from the new length. Through that, you'll be in a position to get several values of the masses attached and the extensions they are causing. Therefore, we need to tabulate the first thing. Tabulate the masses attached to the spring with their corresponding extensions. Then plot masses. This time round, you can even convert them to force against the extension, against their extensions. Then after that, now you are likely to get a straight line through the origin. So a straight line through the origin shows that force and extension are directly proportional. Hence, the Hooke's law verified. Hence, the Hooke's law verified. Hence, the Hooke's law verified. You can also look at part B of the same question. Yeah, part B of the same question. We are told that a load of 0.04 newtons causes an extension of 0.4 centimeters on a certain spring. Determine the load that will cause an extension of 0.6 centimeters on the same spring. So let's get the spring constant first. We shall say that force is directly proportional to extension, meaning that force equals to a constant K multiplied by E. Therefore, for every spring, there is a constant K relating force and extension. So can we get the constant? Spring constant will be given by a force of 0.04 divided by an extension of, instead of 0.4, I can use 0.004. I make them meters so that we get spring constant, which is in SI units. So this is going to be 10 Newton per meter. 10 Newton per meter. All right. Now with the spring constant, we are supposed to say that this spring constant will be so even when the force changes. So a known force, which is the load in this particular case, divided by the new extension, 0.6. Then we do a cross multiplication. Yeah, we do a cross multiplication so that to remain with F now, We need 10 multiplied by 0.6. This will give us 6. Sorry for this. Actually, I'm not supposed to combine centimeters and a spring constant, which is in SI units. You see, there is meters here. Therefore, I'm supposed to convert my 0.6. Sorry for that oversight. So I should now convert. I should convert 0.6 by dividing it by 100 to make it meters. Therefore, the force now is going to be equivalent to 0.06 Newton. 0.06 Newton. That is after cross multiplication. Because there is a 10 there, it will just cancel out. So that is how you're supposed to work out such a question. Look at part C. A student was provided with a piece of wire and asked to make a spring. After coiling the wire on a rod, look at this. The spring appeared as shown below. So a spring has been made there, our figure 5. State 2 ways in which the student can modify the spring to make it stiffer or even stronger. That is the simple question. How can we modify to come up with a stronger spring? We use a thin rod so that we may reduce the diameter. We use, they are coiling the wire on a rod. So if we use a thin rod, we will come up with a spring whose diameter is small, and that will be a stiffer spring. Therefore, use a thinner rod so that the spring will have a smaller diameter. Yeah, a reduced diameter, that is. A reduced diameter. There are many things that we can do. We can also make turns closer so that there are more turns. Make turns closer to one another. Make turns closer to one another. Make turns closer to one another so that the spring has more turns. Per unit length. More turns per unit length. That is something else that we can do among other measures that we can take. Now there is a figure 6 which is showing a setup that may be used to determine acceleration due to gravity. We can see the ticker timer shown there. We can see a tape and a steel ball. Then there is the ground at this point, or rather the floor. What's the question talking about? Describe how the setup may be used to determine the acceleration due to gravity. Describe an experiment to determine how the setup may be used to determine acceleration due to gravity. Look at the steel ball. So the steel ball, in case it is released to fall, then it will be accelerating. Actually, you release it freely to come down. You discover that it will not land at the ground using the velocity that it began with. Very definite that it is going to accelerate towards the ground due to gravity. Yeah, due to gravity. So I should talk about By the time you are releasing the steel ball to fall freely, simultaneously switch on the ticker timer. So switch on the ticker timer and release the steel ball. Release the steel ball to fall freely and start or switch on the ticker timer. And switch on the ticker timer. Remember, the ticker timer is operating under a certain fixed frequency. There is a rate at which the ticker timer will be making dots on the tape. Therefore, the ticker timer makes dots on the tape as it is pulled by the dropping steel ball. Therefore, the steel ball is pulling the tape, as you can see it. Now, if the ticker timer makes a dot here and another dot as the tape flows, because it is being pulled by the steel ball which is going down, you're supposed to know that the dots which are going to be made in the initial stages will be having a different interval from the dots that will be made towards the end of it, or by the time the steel ball will be landing. Therefore, from the different spacings, we can consider an initial velocity and a final velocity. Yeah. So determine the distance between initial dots. Determine the distance between initial dots on the tape and use it to determine initial velocity, that's small letter u, of the steel ball, or simply of the ball. Then after that, determine the distance again between dots. Determine the distance between dots when the ball is almost hitting the ground. Use it to find final velocity, small letter v, of the ball. Then now use the formula to calculate acceleration, whereby we say acceleration is usually given by final velocity minus initial velocity divided by time. And through that, you will be able to get acceleration of the ticker timer. Yeah, acceleration of the ticker timer. Look, part B. A stone of mass 0.02 kilograms tied at the end of a spring is whirled in a vertical circle of radius 1.0 meters. Determine the minimum velocity required. Determine the minimum velocity required for the stone to maintain circular motion, for the stone to maintain circular motion. It's good for you to know that at maximum height or at the topmost point, that is when we require minimum velocity. So in a vertical circle, there is a point, the object will be at the topmost point. That is the time when we will have minimum velocity. And at minimum velocity, we should know that there is maximum height. And at that point, centripetal force is usually equal to the weight of the stone. So centripetal force at that point equals to weight of the stone. Equals to weight of the stone. Therefore, centripetal force is given by mv squared out of r. So this is equivalent to weight of the stone, which is given by mg. At this point, actually, you can see mass will even simplify out automatically. Instead of substituting mass on this side and mass on the other side when it is just the same value. So v squared out of a radius of 1 is equivalent to g. Yeah, so that v squared equals to 10. And how do we get the value of v? By taking the square root of 10. This is going to exactly be 3.162 meters per second. State two applications of centripetal force. These ones are widely applied in the real life situations. Construction of speed governors. Construction of speed governors. We also have a separation of mixtures using centrifuges. Separation of mixtures using centrifuges. Centrifuge. We have banking tracks. Or simply rods. The applications are many. We can use them in turntables, merry-go-rounds, washing machines, etc. There are very many. A reminder about our services here: you can access airtime of any amount for your lines, Safaricom, Telcom, and Airtel. You just go to your M-Pesa, Lipa na M-Pesa. The paybill number is displayed very well on the screen, 73 73 56. This is a number you can even tell your friends freely, 73 73 56. Then now the account number is the phone number that you are buying the airtime for. Your Airtel number, Telcom number, Safaricom number. Then you enter the amount, you complete the transaction, and then you shall receive the airtime instantly. You receive the airtime instantly, and that will be very good for you. Let's now continue. Number 17. It is observed that when salt is sprinkled onto the surface of ice at -2 degrees Celsius, the ice melts. Explain this observation. We all know that pure ice should melt at exactly 0 degrees Celsius. Therefore, we can see now with the sprinkling of salt, it can melt at a temperature slightly below 0. This is to mean that salt is an impurity. Salt is an impurity, and we should also know that impurities lower the melting point of a substance. The melting point of a substance. Imagine if the salt had been added to a certain liquid which was about to boil, it would have boiled at a temperature slightly above its own boiling point. Therefore, for boiling points, an impurity is going to increase it. But for a melting point, an impurity will lower. Yeah. State two factors that affect the pressure exerted by solids. We have a area in contact, area of contact. Yeah. Area of contact. We know that. And also the force being applied, either the weight of the solid itself, or we can take a solid, we place it on a surface such that it is exerting pressure, but now we can also add another force on it, like pressing it downwards. So we can talk of generally weight exerted, weight or simply force exerted, because simply pressure is usually given by force out of the area of contact. Most of the quantities and their factors, or the factors that affect them, can usually be derived from the formula itself, because the formula is the one that shows us how several factors relate. We see pressure, we see force and area. Therefore, the quantities being multiplied to give us pressure or being divided are force and area. And definitely, they are the ones that will affect the amount of the resulting pressure. Look at part C, a very interesting question. This is on a quantity of it now. A very interesting question on quantity of it. Yeah, remember to subscribe to this platform. Remember to share so that you may invite people to the live broadcast. A person mixed 2 kg of hot water at 70 degrees Celsius with 3 kg of cold water at 22 degrees Celsius for bathing. Given that the specific heat capacity of water is 4200 joules per kilogram per Kelvin, determine the final temperature of the mixture, assuming there were no heat losses to the surrounding. Okay, in most of these questions on quantity of heat, we make a basic assumption that heat is just moving from where it is highly concentrated to where it is lowly concentrated without being lost to the surrounding. So can we assume that the final temperature is theta? Let's assume the final temperature is theta. Therefore, the hot water is changing temperature from 70 to theta. The cold water is raising in temperature from 22 to theta. Therefore, from 70 downwards, from 22 upwards, they meet at the value unknown here. Now, we know that heat lost by hot water, heat lost by hot water is equivalent to the heat gained on the other side. Heat gained by cold water. Yeah, by cold water. Therefore, how do we get change in heat? We give mass, specific heat capacity, change in temperature. Mass, specific heat capacity, change in temperature. So a mass of 2 kg multiplied by change in temperature. Okay, we can start by multiplied by 4200 multiplied by change in temperature. So for the hot water from 70 all the way to theta, that is change in temperature, should be the same as 3 kg times 4200 multiplied by all the way to theta from 22. You can see 4200 can simplify out. Then we remain with, let's talk about 2 by 70, that is 140 minus 2 theta equivalent to 3 beta minus 66. Yeah, minus 66. So the value of 5 beta taken to the right hand side equals to 144 or 140, sorry, and we add 66. Yeah, 206. So the value of beta will be, when we divide this now by 5, 41.2. As long as degrees Celsius, as long as you can manage the heat loss and the heat gain very well, and you use the formula here, you can even work out using a change in temperature in a very different way. So you don't really need to follow the procedure I've written, but it's good for you to know that this is so basic. More so when you first analyze where heat is being lost from and where it is being gained to, with the main assumption in these calculations that heat is not lost to the surrounding. Heat is not lost to the surrounding. State 2 possible factors that can lead to loss of heat. That can lead to loss of heat. Remember, water is in a container, so the container is absorbing some heat, but we are neglecting that. We are taking it as a negligible value. So heat lost to the containers having both the cold containers. During that transaction, you can have evaporation. As you transfer, you can have another mode of heat loss that can be evaporation. Yeah, evaporation. So the modes are several. Convection, because these are liquids. Convection, because water is a liquid. We can also have radiation from the containers. Radiation, among other means. Yeah, among other means. We are winding up. Some water at 60 degrees Celsius was heated until it started to boil after time t. On the axis provided, sketch a graph of temperature against time for the water till it boiled. For the water till it boiled. So temperature, degrees Celsius. So we are beginning from 60. So we are not heating from 0. We are not heating from room temperature. We are heating from 60 degrees Celsius. Then assuming that the water was pure at around 100. Now we will have the graph flattening. This is at around 100, which is the boiling water, the boiling point of pure water. Yeah, at 100, we shall have the graph flattening. All this is happening after time t. After time t, because on this axis we have time t. So it is good for you to know that after reaching the boiling point, the graph is going to flatten, or simply there will be increase in time and the heating is continuing, but no increase in temperature. Explain the shape. This is because after time t, the heat supplied is used to, or is used as the, we call it a latent heat of vaporization, as the latent heat of vaporization, and not to change the temperature, and not to increase the temperature, not to increase the temperature. Yeah, that is it. Number 18. Number 18. Explain why the walls of a dam are thicker at the bottom than at the top. Thicker at the bottom than at the top. We know that pressure in liquids, and you know water is a liquid. So you can even say water increases with depth. It increases with depth. Pressure in liquids increases with depth. Now that we have known that, we should know that the walls are thicker at the bottom to withstand the increased pressure, and thin at the top since pressure is less. So at the top, pressure is less. At the bottom, pressure has increased. So where do we need thicker walls? At the bottom, where pressure due to water is very great. Yeah, pressure due to water is very great. We can look at a simple hydraulic lift system. So this one is the effort piston. This one is the load piston or piston 2. We have area 1, area 2. But look, given that the areas A1 and A2 are 0.2, here 0.2 meter squared, and 4 also meter squared, respectively, determine maximum load that can be lifted at piston 2 when a force of 200 Newton is applied at piston 1. So the effort, in other words, is 200 Newton. So we need to know the load which can be lifted. We know that pressure, this is an hydraulic fluid. Yeah. Therefore, we are supposed to know that the pressure applied here, pressure 1, is transmitted such that it will also be equal to pressure 2 on the other end. So pressure 1 is usually equivalent to pressure 2. And how do we get pressure generally? We need force over area. Therefore, the force 1 over area 1 should be the same as the force 2 over area 2 because pressure is uniformly being transmitted. Therefore, an effort of 200, area 0.2, 0.2, equivalent to a known load which can be lifted out of area 2, which is 4. And how do we remain with the second force? We need 200 after cross multiplication times 4 out of 0.2. And this is going to give us exactly 4,000 Newton. 4,000 Newton when you compute. Yeah, 4,000 Newton. State 2 reasons why water is not a suitable liquid for use in this system. We know all the properties which make a liquid to be suitable for use in hydraulic machines. One is that the liquid should not corrode parts of the system. Therefore, you should know that water corrodes. Water corrodes parts of the system. water corrodes parts of the system. We know that again, the liquid which is supposed to be used here should be having a wide range of temperature. But what about water? Just from 0 to 100. That is very narrow. Therefore, water has a narrow range. Water has a narrow range of temperature. Water has a narrow range of temperature. In part C, we are given a figure here, figure 8, showing a pair of scissors. On the diagram, label the load, effort, and fulcrum. Fulcrum is the pivot, the moving part. So this one is the fulcrum. Then where do you apply the efforts? At the handle. Therefore, this is where the effort will be applied. And whatever is being cut by the scissors is the load. Therefore, we place the load at that position. So that is a rough labeling of fulcrum, effort, and load. And I hope you people are following. I said you can comment. Yeah, you can ask a question. Let's know where you are following us from. Let's know whether you are getting us clearly so that we may know where to improve next. Otherwise, thank you so much for the support that you are showing. Remember, our consultation line remains 0704 153366. This is also our M-Pesa line. You can use the same number to appreciate the good work that we are doing in Shifting Grades online school. Yeah. Explain how the velocity ratio of the given pair of scissors may be reduced. How can we reduce the velocity ratio? Remember, VR is usually distance of effort out of distance of load. Therefore, we can have a reduced VR by increasing distance of the load. Increasing load distance. Load distance. Again, according to this relation here, we can do so by reducing effort distance. Effort distance, because it is directly proportional. Effort distance is directly proportional to the velocity ratio. When we reduce effort distance, velocity ratio also reduces. Increasing load distance. When we increase load distance, which is inversely proportional to velocity ratio will be lowered. State the reason why it is important to minimize velocity ratio. To minimize velocity ratio is so that we may increase efficiency of the machine. Increase the efficiency of the machine. Remember that efficiency is given by mechanical advantage out of VR multiplied by 100, and we make it a percentage. Therefore, from this formula, you can see that velocity ratio is inversely proportional to the efficiency of a machine. Therefore, when velocity ratio is increased, is minimized, when this one is decreased, we will have a greater efficiency. Efficiency is the output, how effective a machine is. So that is the paper. Remember to subscribe to the platform. Remember also to use our model here for getting airtime. If you want to purchase airtime, just go to your M-Pesa, Lipa na M-Pesa, the pay bill number 737356, account number, your own phone number. Then you enter the amount, you complete the transaction, the airtime shall reflect instantly. Otherwise, thank you so much. In our next live broadcast, please come with a friend. Have a good night.